Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the 2.5 operations on function and also the composite function. So this is the basic of the operation on function. So the first one, we have the summation, difference, product and also quotient. So when we try to find out the sum between two functions, so f plus g is equivalent to f function f plus with the function g. The difference is when we have f minus with the function g, and when you have product f function f multiply with the function of g, and then for the quotient f divided by function g. So they are this is the way. So to find out the domain for the operation on function, summation, difference and also product, so the way how to find out domain is the intersection between the domain of the function f intersect with the domain of the function g. And then for the quotient, the domain for the quotient is equivalent to domain of the function f, they intersect with the domain of the function g, but provided that the function of g cannot be 0. So we have additional condition to find out domain of the quotient. Now let's look at to this exercise. So you are given these two functions f and g. So we need to find out the product between function of f, g. So if we have f, g, meaning that the question asks you to find out product between two functions fx times with the gx. So if the question give you in this form f gx like this, so this one is referred to the composite function. So this is the difference between product and the composite function. So for the composite function, we are going to learn after this. Okay, now let's look at to this question. So we want to find out the product between two functions and also quotient and determine the domain. So in order to get the function, I think you know how to get the function. So it is easy. So for the first part, we have a f times with the function g is equivalent to the square root of 9 minus x squared times with the function of x squared minus 4. You can just leave it your answer like this, or you can just put like we have 9 minus x squared and x squared minus 4. So it is the same term. So this is our function fg. And then for the next one, we want to find out the domain. So the domain of the product between two functions, first we need to determine domain for the function f. So we have to go back to the determine the domain of the function in 2.1. So this is in the category of the root of even function. So under the square root, so all the terms inside the square root, which is x in general, must be always greater than or equals to 0. So therefore our function inside the square root now is 9 minus x squared, and it must be greater than equals to 0. Whenever you have the terms of the quadratic, which is the values of a is less than 1, or the values of a is negative number, so it's better for you to make it in form of positive. How? In this case, you have to multiply both sides with the negative values. So we have here negative, multiply both sides with the negative 1, so you will get x squared minus 9, and it will reverse the inequality sign. So it will become, instead of greater than equals to, so it will become less than equals to 0. So next, what we have to do, we have to get the factor. So in terms of or, you have to factorize completely. So it will become x minus 3 and x plus 3 is less than equals to 0. So we have two zeros here, so which is the values of zeros, or the values of x is either 3 or negative 3. So how can we solve this inequality? So once we already put in terms of factor form, we have to is either draw the sign table or by using quadratic graph. So we have here small graph together with that two zeros. So one of the zeros, the lowest is negative 3, the next one we have 3. Since the last inequality notation here is less than equals to, therefore our shaded region should be here. So this is our area, and from this area our domain is from -3 until 3. So this is not the final answer because this is only the domain for the function f. So we need to find out domain for the function g. So what is the function g? It is also square root. So the same properties like our previous function f. So it is x squared minus 4 should be greater than equals to 0. So this is domain of the function g. X squared minus 4 is greater than equals to 0. Then again we have to factorize completely, so you will get here x minus 2 and x plus 2. So greater than equals to 0, again we have to have another quadratic graph. So we have here quadratic graph together with the zeros. We have -2 and 2. Since it is greater than equals to, therefore the shaded area should be on the left and also on the right side. So from here, our domain is from -infinity until -2, close, because there is an equality sign here. So close, union with the other values of x is 2 until infinity. So what we need to do with these two domains, so we need to find out the intersection. So how can we combine or find out the intersection between these two domains is by using line graph. So in this line graph, we have to put all the zeros that we have. The lowest is -3, -2, 2, and also +3. So for the function of f just now, our domain is -3 until 3. Therefore, our line graph should be like this: -3 until 3, and it should be dot. And then for the second function, which is the function of g, the domain is from -infinity until -2. So this is the first part, union with the second part, which is 2 until infinity. So the line intersect at the values starting from the -3 until -2. This is our intersection line, and another intersection line on the values of 2 until 3. Therefore, the final domain or the domain of this function f over g, so we can put like domain of the f over g, or you can just put in words domain. So you can just put in words domain. So we have here from -3 close bracket until -2, close union with the 2 until 3. So this is the domain of the product between two function f, g. -3 until -2, union 2 until 3. Then the next one, we want to determine domain of the f over g. Okay, now we want to determine for the part B, find the quotient f over g and its domain. So what we have to do here is, first we need to find out the function. So f over g, or we just put fx over with the gx, and then the function is square root of 9 minus with the x squared divided by square root of x squared minus 4. So we can just leave it our answer like this, or you can also rewrite as square root of 9 minus x squared over with the x squared minus 4. So this one also can. So both are acceptable. Okay, the next one, we need to find out the domain of this quotient. So it's like our previous domain for the product between two functions, which is domain f must intersect with the domain g, but we do have the additional condition, the function of g cannot be 0, because now we are dealing with the rational. So the x squared, or the square root of x squared minus 4, is the function of g, so that terms cannot be 0. So when you try to find out domain for this function gx cannot be 0, so x squared minus 4, instead of greater than equals to, you can just put as greater than 0, because that function of g in your denominator. So we can just factorize as usual, x minus 2, x plus 2, and it should be greater than 0. So it seems like our previous step, but actually our previous function here, for you to find out the domain, so we have include the values of 0, because the function of g is not in the denominator. But since we do have the function of g in denominator, we need to exclude the values of 0. So that's what will become like this. So we have here the lowest is negative 2, and this one is 2, and it should be greater than, so this side and this side. So our domain for the g here now is become negative infinity until negative 2, open union open to until infinity. So since we already find out domain from the previous part, so we already find out domain for the function of f, which is we get just now our domain for the function of f, negative 3 until 3. So we don't need to show again how to get the domain of the function f. So what is important now, we can just look at back our new line graph. We have negative 3, negative 2, 2, and also 3. So just now our domain for the function of f is close bracket negative 3 until 3. So when you when you try to find out the intersection line between that two domain, so for this part, for the domain of the function g, so on the values of negative 2, it should be whole. On the values of 2, it also should be whole. So in other words, our domain between the function f over g, so it is equivalent to negative, so this is our intersection line, so negative 3 close until negative 2 open. Why? Because one is dot, another line is a whole, so that's why we need to open, and then open a union with the open bracket 2 until 3 close. So this is our domain for the f over g. So just now the domain here is referred to the domain of fg, so this is domain of fg. Okay, can you try out the question from the exercise 1 part 2?